Hello everybody and welcome. I'm Christian from ISI and this is the first mini devlog. So I've been working on this simple project over the last few weeks, over weekends and stuff, in between, just for enjoyment and education and stuff. So this project has mostly been focusing on rendering and data management and stuff, because those are things that I enjoy doing but I don't do a lot of. It's a bit of a bug. So this system is all run by billboards. It's all done with a particle system. So all these trees, all the rocks, they're all one particle system. So to get them all to look different, I'm actually pretty proud of how this one turned out. But I'm using an atlas shader that I created. So what I do is I give it an atlas sprite, and then I tell it atlas scale. So that's pretty much the number of sprites that are in this atlas. So I've set it to 2 by 2 because there are 4, even though I've only got 2 in it currently. So I've made this Atlas shader, I call it Atlas Particles. It's done with the lightweight render pipeline, just because I'm using lightweight rendering and I thought it would be easier than writing it. So when this loads up, I have used, oh, it's a little bit hard to read. I will turn this off. Okay, so the way it works is I've got my Atlas sprite. I've got, of course, the sample texture, which goes to color in alpha, because this is particles, so I need it to be cut out. And I've set it to transparent, just to make sure you can actually the alpha actually works. So I'm using a tiling offset node, and I'm just getting atlas scale, or I'm getting 1 and dividing it by atlas scale. Now this gives me increments of, this means that if I've got 20 sprites on the sheet, or 25, so it goes to 5 by 5, and then I divide that, that will mean that a tiling will shrink it such that a value of 0 will give me 1 point, and a value of 1 will give me the opposite of a single sprite. So this makes sure that I'm only rendering 1 sprite at a time. And then the offset, I'm using the vertex color. So I'm using the vertex color because particles, the color of the particle is stored in vertex color information. So that's really the only data I can easily pass into the shader quickly. And so in the particle system, if I can find it, here it is, under world renderer. Oh, it's not in here, it'll be in the world generator function. So I've got this get atlas chord function. So I've got up here, I've got the particle system.particles. So that's a array. I use that for updating them because they're all data, they're not actual objects. The atlas size, so that tells me the same as what I've got in the shader, so that's 2 by 2. And then I've got a vector2 int for the tree atlas location and the rock atlas location. And then I've got a get atlas chord function, which given a vector2 int, it gets the x coordinate and the y coordinate, and then it turns them into a color and then returns that color. And so then when I'm setting them, I get the start side, and then I set the start color to get atlas chord of the tree atlas location. So this is where I generate a tree. So I generate all this data and add it to a list so I can keep track of the data. And then I instead emit a particle. So by using the different colors, I use the red and the green channels as x and y coordinates. And that allows me to offset the sprite so that it actually shows the correct one. So that one is pretty good system, and it works quite well. Like it's a lot more efficient than using separate particle systems. Also, using separate particle systems, they don't render correctly because I can use, like in the renderer here, I can sort by distance. But if these separate particle systems, they will still render in front of each other or behind each other. Like I can't set that for individual particles. So the only way to get them to actually render correctly is to have them all on the same particle system. But because it's all data, it's easy to keep track of them, and then I just have to set the atlas offset, and then it all renders very well. So that's good. And then for the units themselves, because that's the second sort of aim of this project I've been working on, is the queue system. So I've just got 3 queues, a high, medium, and low priority queue. And then I just add jobs using a set job. It's a static function. Where is it? Oh, it was a static function. That's right, I had to change it because I'm now using a faction controller, because this will eventually have AI that plays as well, and it'll have its own sort of civilization that'll slowly build up and begin attacking you and stuff. And so I just have to keep track of the faction controller, and the faction controller keeps track of the job controller. It'll keep track of other things as well that they need to know about, like enemies, known enemies, neutral enemies, and things like that. And so the set job function just takes in a job and a priority. It's defaulted to normal, so if I don't give it 1, it'll just set it to normal priority. So I can set a high, medium, or low job. And then in the fixed update, I'm using fixed update because if I use normal update, it's affected by frame rate. But a fixed update will happen the same number of times per second. and if it can't do enough, it'll actually slow the game down a bit. This is done because I have a speed controller in the game, and if you set up too high, what would happen is I was using normal update, is that it would become different. Like the same things wouldn't happen if I had it going quickly as I had when it was going slow. And that's not what you want in a game. You want it when you go fast to be the exact same game, just faster. But what happened is that the units couldn't keep up. It couldn't be giving jobs fast enough, how fast things were growing and stuff like that. And so things would sort of get out of sync compared to what it would be like if I'd had it running normal speed. So I had to use fixed updates, so the same number of ticks will happen no matter what speed I'm going at. But yeah, I just check if there's a unit available, and if there is, it checks if there's a high priority job available. If there is, it'll assign that job. So this just checks if the job is still valid, and then it dequeues a unit from the idle units queue, and then it sets that unit's current job to equal to that job. And then if there's no high, it just does that for the medium and then for the low. So it'll always do high priority jobs first, and then normal priority, and then low priority. And then in the field, this is where I'm setting the jobs. So I've just checked if the produce is greater than the harvest produce, so that's a limit where once it passes that, I tell them they need to go and do it. So it'll set the job, it'll set a normal priority because it hasn't set one, it just does normal. And then it checks how many units it will take using the maximum produce divided by the average harvesting speed of the units. And it determines how many units it'll take to complete that job in 1 second. And then for each number of units it'll need, it adds a new job at a low priority. So if there's no jobs that need to be done, they'll help someone else who's in the middle of doing a big job. But if there are jobs to be done, they will go and continue doing those jobs. It just makes it better because if you have like a really big job, like one of the larger farms, it can take one unit a long time to do it, and without multiple units working on it, it can take them a very long time. But yeah, that's all, and then I just set the harvestable to true, and that's how I do the is still valid. It just checks if this is harvestable, and that returns harvestable. So if the job's still being done, it sets it to false, harvestable to be false, and if it is finished, it sets harvestable to false, and if it's not finished, it sets harvestable to true, and that just makes sure that the unit won't run to the other side of the map to a farm that's already been harvested. It'll check before he starts doing the job. But yeah, so that's about all I've done in this project. This one was mainly for fun and enjoyment. I might work on this in my free time, and this may become my next main devlog project once I'm finished Lightbots, because I do quite enjoy this style of game. So I'll just see what happens. But anyway, that's all for now. See you next time.